All right, this is the Bernoulli effect. Um, it's a basic physics 2 principle, getting started with fluids. Uh, well, what is it? It basically describes the key components of fluid in motion. The two big ones are going to be pressure and velocity. So what I mean by that is that the velocity actually affects the pressure. The higher the velocity goes, if we're talking about the ball, on the right, if we're assuming those blue lines are air patterns, the higher the velocity over the ball, the lower the pressure. Okay, and vice versa. The lower the velocity, the higher the pressure. Higher the velocity, the lower the pressure. Right? Here's our formula where the atmospheric pressure is equal to the density times the gravitational acceleration times the depth or the height of the fluid, plus 1/2 of the density times the velocity of that fluid squared. Well, that's going to be constant everywhere. So as density might change, it affects pressure. As volume might or velocity might change, it will affect the pressure. Uh, those can vary locally, but overall the sum of all three of those terms has to remain constant. There's some actually really important applications of Bernoulli's. One of them is part of the lift that is applied to an airplane wing. If we look at the airplane wing, we can see that the teardrop shape, if we're looking at a cross section of wing, creates a larger distance for air to travel, which causes it to move at a higher speed, right? Right? If we're looking at the air above and below, well, the air doesn't just start moving quicker. It doesn't separate from the air below it. It has to move faster over top of the wing to keep up with the air below it. Okay, so as it moves faster over the wing, it creates a low pressure zone, which causes the wing to move upwards. Same idea with a sailboat. You can actually sail into the wind. The sail will push on, or the wind will push on the sail, create that same teardrop looking pattern of the wing, and you can actually sail into the wind. It actually creates a low pressure area on the side of a baseball when thrown with enough spin, and that we can call the low pressure area on one side of a baseball, which will cause it to curve in that direction. Right? One big thing with AP Physics is the Torricelli's theorem, which is going to be a simple derivation of Bernoulli's theorem, but there is one important caveat, is that we have to assume that the hole on the side is small enough in relation to the hole on top of this water tower that it appears that the velocity of the larger opening, the water moving in that tank, is approximately 0. Um, you can get away with a lot. It doesn't have to be that close, but it should be much slower than the smaller opening on the side. All right, that's a quick run through of Bernoulli's. If you have any questions, get in touch. Thanks.